All right, guys, let's take a look here. Yeah. So, everybody cool with what I did here? All right, don't forget when you rewrite roots, real quick, because I always get somebody who puts the power together incorrectly. Where are roots on most plants? On the top or on the bottom? On the bottom. So the first time I tried to say this to a class, I had a botanist, a future botanist in the room, and I said, roots of plants are on the bottom, and they went, well, actually, tubers, be quiet. But just to help you remember, the root on that piece is 5, so it's on the bottom. And the power is on the top, it's powerful. So when you rewrite radicals, roots on the bottom, power's on the top. Okay. So now that I've gotten written like x to the n, every single piece, the derivative should be pretty straightforward, right?
12x 3 third, 12x 3 minus 6, so that's 12x. Plus
6 fifths
Good.
x.
6 fifths x to the negative 3 fifths, plus 9x to the negative 4.
Yeah, this is where people make a mistake real easy. Your brain thinks you go down, that makes it 2, but it, of course it makes it more negative. I like it. We already did b. Cosine 2 is just a constant. Yes?
Is it okay to leave the answer like that, or would you like us to like rewrite it?
This
as
is
a
fine.
root?
This
That's
is
okay.
fine. Yeah, the funny thing is, the way you write this answer only matters if, depending on what you have to do next. And we don't have to do anything next for this problem, right? So yeah, but if I had to solve it equal to 0, if I had to set it equal to something else or something like that, I might want to rewrite it in a different form, but I got nothing else to do, so I can just stop there. Yeah. And to be really, really honest, I wish we had never invented radical notation. Because fractional exponents are radicals. We don't need, but oh well, they exist, so too bad for us. Okay. B is 0, because it's a constant. What do I do on part C?
I brought it up. I brought 2x plus 3f.
You can, yeah, I'm going to do it both ways, I think.
Okay.
Let's do it the straightforward way. This is obviously a ratio, so what rule do I use directly? Quotient rule, right? So what's quotient rule say to do?
3 e to the x, prime of that,
Good.
times 2x plus 3 minus 3 e to the x, 2x plus 3 prime, over 2x plus 3 is
Yes. So of course, what's 3e to the x? Its derivative. 3e to the x, that kicks so much butt. So 3e to the x, and then you get 2x plus 3 minus
2 is 2.
2 all over. Let's see if you guys are cool with this. Wouldn't this be 3e to the x? Wouldn't this be 6x e to the x? Well, let me just write it out. 6x e to the x plus 9 e to the x minus 6 e to the x. And I could take out, now it's cool if you stop here, I could take an e to the x, I could actually take a 3 e to the x out. But like you asked earlier, there's no need because there's nothing to do after this, right? The important thing is this won't cancel with anything on the top. So there's really no true simplification to do. How do you guys feel about that? That's
Surprising.
no, don't be surprised. Okay. Let's do this a different way. I kind of want to show this off because it's interesting. I'll do it over here and then I'm going to erase everything. So if I brought the bottom up, like that, right? Is that cool? So if I bring the bottom up to begin with, this is what young Jeff did all the time, because I was like, quotient rule sucks. I'm never going to use it. Thanks for giving it to me. Gonna give it right back. So I always did this. The problem is, here's the problem with this problem, and this is why come to think of it, I can't do this yet. We're gonna have to do this later. We still don't officially know how to handle a function inside of another function. And I pointed this out last time. I'm gonna show you why that's a problem. And then we're gonna kind of work, we're gonna create a new rule for functions inside other functions, right? So we actually can't do that, not yet. Okay, so what about, so this one again, all the E stuff, it's all constants, E and pi, so that's one number, that's a number, and its derivative is 0.
I have a question. So how come on like the 3.1 homework you can bring like a square root x up to the top even though it doesn't have a
Because, is there a function inside of another function? No. This is the square root of x. Is there a function inside of another function here? Yes. There's a 4x squared minus 7x inside of a square root function, right?
Oh, okay.
So this is something we can handle before section 3.4. This is something we need section 3.4 to help us with, and we haven't done section 3.4 yet.
Okay.
And I know right now you're all like, what the shit, what's the big deal? Why does that change anything? Well, because it does. It should make sense. I can't just think that this derivative is like the square root of 8x minus 7 or something, because that's pretending like the square root does nothing. Okay, so that's obviously not. Okay. So what about this guy? What's the main rule happening here? Product rule, I love it.
2 theta squared cosine theta plus theta cubed times negative sine theta.
So I'm going to be a little pedantic here. I'm going to write this. Again, the simpler the derivatives, the less you have to do that, but I really want you to kind of get in that process because, again, the biggest mistake people make is trying to do too much at once, which is you being mean to yourself. That's my job. So then the derivative of theta cubed, 3 theta squared, I like it. And then this one, what's the derivative of cosine? So I'm going to make that a minus. Cool. And then, this one you could use quotient rule and drive yourself slowly insane, or you could realize, now watch this, this is kind of cool. I don't know if you guys have ever seen this. The only time that factoring the top would help me is if b plus 1 was a piece of the top. You guys agree? If b plus 1 is not a piece of the top, I'm not going to factor the top, am I? So let me write it as if it's true. So doesn't this have to be 3b to make it 3b squared? What would have to be here to make it negative 1? Negative 1. Now let's check. I know I get 3b squared. I know I get negative 1. So I get minus b plus 3b is plus 2b. Hey! If it didn't make the middle term, I would erase it and just do quotient rule, because then factoring wouldn't help me. But here, what is this function actually?
And prime is
Freaking 3b minus 1. Now notice, real quick, why didn't I put a prime here?
because
I haven't taken a derivative yet, but people get into the habit of just putting a prime and then you think you're done. You haven't taken a derivative yet, you just simplified the function, yes? So now f prime is just freaking 3. Chapow! So definitely stop yourself when you're given a problem to take the derivative. Just see, is there any simplification I can do? Because that's you being nice to yourself. To make this problem simpler, isn't that nice? You can finally do that. I don't like your problem, Jeff. I'm going to make it easier. It's the same problem, so it's all good. How do you guys feel? Obviously, you need a lot of practice. Maybe not as much practice as some of you thought I'd given you, but you need practice to get this in your head, but this isn't too crazy, and I desperately need you to remember this was built on the limit definition of derivative. Everything comes back to that, because that's what builds derivatives, and that's based on algebra. Yeah.
I'm still a little bit confused. How is that more than one function? Isn't the 2x plus 3 just like a polynomial or a linear function?
There you go. What'd you just say?
So
It's
then
a linear function.
Yeah.
So the important thing is, the part that is inside the negative 1 power, is its derivative something other than 1? Yes.
Okay.
Yes.
That makes
So
sense.
its derivative is going to mess things up.
Okay.
it needs to be taking into account.
That makes sense.
Okay. Sort of like, why don't I have to use product rule for this? Why don't I have to use product rule for 7 times sine x? Isn't that 7 times sine x? Isn't there 2 parts?
Yeah.
Why don't I have to use product rule?
One is a constant.
Because the derivative of 7 is
0.
0, so its contribution is going to disappear. So, we're going to build up. I first want to prove to you that there is an issue with a function inside of another function. And we can do that very directly. I can show you right away that we're not allowed to look at it the way we were looking at earlier, simpler functions. It won't work. And the quickest way for me to show you that, has everybody got what they want from this business? Okay. More than you wanted? Okay. There's a really, really, really crazy simple illustration that we need more help. Where am I pointing right now? Okay. Doobie-doobie-doo. Okay. So what if I had, well, let's do something related. Let's do this. So I can kind of do this 2 different ways. And if the 2 ways don't agree, there's a problem with one of them. All right. So the first way I'm going to do this is to just simplify the function, right? Is that cool? So I'm going to FOIL it out. 6x, 6x. There's no arguing that that is that, correct? So this derivative I know is correct. There's no other way around it. So what do I get for this derivative?
8x plus 12.
Kick ass. Now, what if I try instead? Because I know the derivative of variable squared, isn't that just 2 times variable to the first power? Right? Derivative of x squared is 2x, correct? All right. So what if I try to do, okay, f prime, bring the 2 down, times this to the first power. And of course, what do you get?
4x plus 6.
Is that? No, in fact, you can see exactly what is missing. You can see exactly, why is this wrong? It needs what to become the right answer?
Double itself.
It needs to multiply by 2. And what's the derivative of the inside?
2.
Freaking 2. So I really want, again, what do derivatives measure? Rates of change. So if I'm on a, what do you call it? Not a treadmill, but in the airport, the walkway, right? And I'm just standing, my rate of change is based on the walkway. If I start walking, am I not going to add my own rate of change on top of the walkway? So somebody standing next to me, I'm going faster even if I start walking, of course, right? Of course. So the rate of change, this is like the walkway, and this is me walking on the walkway. My rate of change should come into play. Okay, maybe. If this was just x plus 3, that would be 1. It would be multiplied by 1, it wouldn't change. In fact, let's do that real quick. What if I had, let's make it, it doesn't matter, Jeff. X plus 3 squared. So this, I could do it like this, right? I'm just going to do it kind of quickly. Woohoo! Or I could do it like, bring the 2 down. Power goes to 1, bring the 2 in, I get 2x plus 6. So they're the same. Yes, because the inside rate was 1. If I multiply by 1, it's the same thing. I really want...
So it's just like another shortcut to find it?
Not a shortcut. It's a necessary method to find it. We have to multiply by the contribution of what's inside of the person on the walkway. I have to multiply by that contribution.
So it's a necessary, so that just happens to be faster.
Oh, hell yeah. Because is the inside function always going to be a nice linear function?
No.
Oh, hell no. So I need something that works no matter what. I mean, if the inside function was just a linear function, I can just do that and multiply by whatever the slope is of the inside.
Will this work on like,
It'll work on
functions?
everything. It'll work on everything that is a function inside of another function. Yes, sir?
So like another example of like the, I don't know, like 4x plus 8, whatever, and then you do like, first like we get on this side, but what we gotta do is double it again, I guess you could say, like, so it's like, another example, 4x plus 8, and then squared, right, and then you do, bring the 2 to the front, and most times it gives like that, like gives like that, whatever that is, and then what we gotta do is do times 2.
Well, times 4 in that case, because now the slope of the inside is 4. Right? If you have 4x plus 8 inside, isn't the inside slope 4? So that's what's missing. What is missing here is the derivative of this, isn't it? If I multiply this by the derivative of the inside, won't that become this? Okay, so let's prove that that's the way this works. It seems as if, let's prove this before I do more of this stuff. All right, and I want to keep that up there. We're going to do this eventually. This one here. All right, and this proof, all right, I've kind of tried to streamline it as much as I can. It can definitely get out of hand pretty quickly, this proof. No, I don't want to do it that way. That's gross. Okay. There is a very gross way to do this, and then there's a really not so gross way to do this. All right. So let's say, so what I really want to investigate is how would I figure out the derivative of a function that is actually a function inside of another function. So this is exactly the process we used for getting the product rule and the quotient rule, right? If you write an expression that represents every single function that has some condition, it's a quotient, it's a product, it's a composition, and you do the process, you have proven a rule. You have created a rule for every function in that form. This is going to be a little gross, though, isn't it? Let's see. Can you guys take a second? Don't say anything. Let me give myself some more room. Can you write down what this would be? Don't say anything. I'll get it started. Actually, yeah, let's do this first, and then I'll go to a better one. Very few people are ready. Now look here, let's do it in terms of m. What's m prime? Would it be m of what minus m of what? Well, no, what m? Would it be m of x plus h? M of x over h? Isn't that what it is? Right? Okay. Now fill in what is m of x plus h? What is this? F of g of
X plus h.
yeah. And what's m of x? It's freaking this. Right? Okay, I like it. Let me see. All right, let me try this way. Now that I've really, there's a little bit, screw it, I'm going to try this one. This, I don't know if you guys understand, this sucks a lot. We can't do the add, subtract, the same thing, because the problem isn't, I got a part multiplying or dividing, I got a part inside another function. What the shit? What the shit? Okay, so, side note. All right, we need a little help. I'm going to do it this way. Why am I doing it this way? I don't know, because I want to. I didn't give myself an example. I love it. What would this be? Let me think. Yeah. U of x plus h minus u of x over h. This is an easy one. What would that mean? What would that give me if I did it? U prime, right? U prime. It doesn't really matter what this is. All it matters is that this is h more than that, and the bottom is this minus this, correct? All right, so what about if it was u of k of x plus h minus u of k of x over k of x plus h minus k of x? Does that follow the idea? Is it the input here and the input here is down here, so it's the outputs, right? It's u of this minus u of this over the difference of the inputs. Isn't that y2 minus y1 over x2 minus
So
x1?
that would be u of k prime.
So it would be u prime of k of x. Because what's my input now? My input's not just x. My input is k of. But it matches the form is what's important. I love you guys. This is weird as shit. It is. So just accept that it's weird as shit, but still try to understand it. So the idea is, if I set up this limit, and I have function evaluated somewhere minus function evaluated somewhere over the difference of those inputs, that is y2 minus y1 over x2 minus x1. That's what that is. It's equal to the derivative of this function evaluated here, isn't it? Isn't that what we did here? So that there it is. Now, do we have that here? Do we have that here? What should be on the bottom so I can use what we just said?
G of x plus h minus g of x.
Yes. So the same way that last time we added, subtracted the same thing. So overall we did nothing. I'm going to divide and multiply by the same thing. So overall I did nothing. So what I'm going to do is this. So I'm going to move the h over. Here's this, and I'm going to divide this by g of x plus h minus g of x, and multiply by g of x plus h minus g of x. The only time I cannot do that is if this equals this, and this is h away from that input. So unless it's a flat line, in which case I wouldn't even do this anyway, it works for everything else. There's a bit more technical detail there, but I'm trying to get to the heart of the idea. I don't know if you guys are with me at all. Do you guys kind of get what I'm saying over here? Do you see how this was u prime evaluated at that point? So that's why this is u prime evaluated there, because that's the thing I'm trying to get towards. It's in the same form. So now, do I have something that looks like that did?
Yes.
So the limit as h goes to 0, this is going to be what? You can do it.
It's going to be f prime of g of x, and then you multiply it by g prime of x.
Yeah, the limit of this looks really exactly like you said, right? That completely looks familiar. What the hell's that again? The limit as h goes to 0 of this is just
The limit of
g
g of
prime.
x.
Isn't that g prime? All right, so now you're all going to say, look, we got here, and you're all going to say, what the shit does that mean? Right? That's a great question. What the shit does that actually mean? Oh yeah, I do. So let's go back to an earlier problem we did. What was it, 2x plus 3 squared, right? What's the inside function here, obviously?
2x plus
Yeah, so that would be like g of x. And what's the outside function?
x squared.
Yeah, it's something squared. So what this says is, if I have a function inside of another function, I take the derivative of the outside function as if this inside was just x or whatever. How do I take the derivative of something squared?
Multiply it by 2.
The 2 comes down in front of something to the first power. Times. And now you see why we call it the chain rule. I got to link to this. I got to link the derivative of the inside. That's what this says. So take the derivative of the outside with that in it, but then the inside has to get a turn. It's still that idea of everything gets a turn. I love you guys. All right. So this exactly matches up with what we were saying earlier, right? This derivative is 2 times 2 is 4, and so I end up with 8x plus 12. You guys with me at all? A little bit? This, and I'm not saying this to freak you out, I think this is one of the more difficult derivative rules to understand and apply directly, correctly. It just is. That doesn't mean you're going to have a lot of trouble with it for sure. I don't know. All right, so let's try some slightly more interesting problems. So let's just take the immediate next step up from here. Would be something like this. Let's see. Now, if I don't say, you always have the option to multiply something out. If I just say find the derivative, if I just said find the derivative and I didn't say anything else, you could totally foil this. Yes? Do you want to? Do you want to write this 11 times? And then multiply, and then you're not done and they say test is over and you're like, that was wrong. Right? Okay, so this immediately has usefulness. So how do I do this? It's really easy right now to tell what the inside function is and what the outside function is. If you need to, you can, sometimes I use the letter U. I could say U is this, so then U prime, what would U prime be?
8x squared.
No. 12x squared minus 1. And then the outside is something to the 11th power. So F prime would be 11 times something to the 10th power. Now, I mean, you can kind of do this and then throw it back in. Some students like to do that. I personally try to get you away from that because I want you to not do too many parts because sometimes they don't come back together correctly. So what I'd rather you try to do is to just go ahead and tack this directly. The outside function is first. How do you take the derivative of something to the 11th power? Yeah, the 11 comes down. Times the thing, right? This is a thing, thing 11. 11 comes down in front of thing, and now it's to the what power? 10. Isn't that how it always has worked? Whatever the thing is, there's no reason to change it. There was 11, now there's 10 of them, because that's how derivatives work. I like it. Times the derivative, the inside gets its own turn. So the outside gets a turn, the inside gets a turn. And we call it chain rule, and you'll see why in a minute, because you could have multiple links. You could have a function inside of a function inside of a function inside of a function, like a Russian nesting doll. Exactly. Right? Which is a cool thing and a cool show on the Netflixes, on the YouTubes, on the internet. It's not the YouTube, sorry. And then what do I do with kind of the last step here? It's not too much I could do. What do I do here?
12x squared minus 1.
Yeah, 12x squared minus 1, just like we got over there. And then I could kind of bring this out. Bring this out here. What's 11 times 12?
132.
Sweet. And this is the most I can do with this shit, yes? Dear God, don't freaking multiply this thing out. Please, dear God. Don't do that. Please. Okay, but don't stop here. Go ahead and bring this out like a coefficient, like it should be, right? Put these together. Okay. Now if I ask you, find where this is horizontal, you set it equal to 0, it's already factored. I mean, you guys, okay. So that's why I was saying earlier, it depends on what the next question is as far as how I want it to look. All right, now let's get funky. Let's do this one real quick. This one's not that big of a step from what we've been doing. Oh, Jeff, you can go So remember, this is that earlier problem, and we brought the 2x plus 3 up. Whatever we do, we better get the same answer we got before, or else we can throw this out. So, what's the main rule that I want to apply here? The main one. How many rules do you see in there? Do you have a function times another function?
Yeah.
Yes. Do you have a function inside of another function? Yes. The main thing is function times function. The main thing in this is the product rule. When's chain rule going to happen? When I take the derivative of this piece in the product rule, right? But the product rule is the main thing happening. So how do I do product rule?
F prime.
Yeah, first dude, derivative, leave the second dude alone. Plus, first dude times the derivative of that. Well, I can erase you now, I got you. I got you. I can make my hand all colors, yeah. You guys, is that cool? Right. So again, the beautiful thing about this is you're just writing the rule. You're not actually doing any work. Now you can identify your work. This is work. What's that derivative?
3x.
Bite. And now this is work. And we identify the fact that this is going to be a chain rule because I have a function inside of another one.
-2.
Careful. What's up?
The derivative.
Negative 1 comes down.
2x plus 3 to the power negative 2.
Times. Is that cool? The negative 1 comes down. Then the thing is to a 1 less power. That's how it always works, right? When you have something to a power, that's how it works. But then the inside gets a turn. And just for the sake of writing, isn't this 2? Right, let me see how I want to write this. Isn't that 2? Is that cool? Okay. All right, let's see. So let me write this like this. Let's see, minus, let's see, 3e to the x times 2 over 2x plus 3 squared. Do you guys see how I got there? Minus, bam, 2x plus negative 2, so those 2 go down. Is that cool? It's negative power, so it goes down. That 2 I brought out here. Is this what we got before?
Yeah.
Not yet, right? What did we get before? What did we get before? Somebody help me out? Somebody got that written down?
6x e to the x plus 9e to the x minus 6e to the x over 2x plus 3 squared.
All right, so that's what we got. But there's still stuff I can do, right? Can I combine these fractions the way they are? No. What does this guy need?
2x plus 3.
Another 2x plus 3. And do you see how I get 6x e to the x, is that cool? 3x, 2x. 3e to the x times 3 is 9e to the x. Minus 6e to the x. All over that square, same answer, right? Same answer. So that's what I used to do. But I couldn't do it until I learned chain rule. And then when I learned chain rule, I'm like, wait a minute. Sweet. The trade-off is you'll have these fractions you got to put together, right? Which really isn't that hard, but still. Okay. I don't know how you guys feel right now. Let's do one more, and then I'm going to unleash you on the ones on here. Release the packet. Okay.
Somebody calls Davy Jones.
Davy Jones, that's right. Or I'm thinking about Clash of the Titans. The original.
You thinking
The
of
original.
80s?
Yeah. Release the crack. All right. I'm not thinking about recent legal things. Anyway, I guess you can pay attention. How about this here? So let's do a Russian nesting doll problem. Let's see, sine squared of cosine of 5x. Oh, that's so beautiful. all like, well, beauty's in the eye of the beholder, so. All right, now, one thing about trig functions, we put the square there, which sort of doesn't really capture what's really going on. This is what's really going on. So what's the most inner function? Cosine, yeah. Well, actually, the most inner function is 5x, which is inside cosine, which is inside sine, which is inside a square.
Are we watching Inception, but we're also in Inception?
Yes, exactly. You're watching it, you're in it, you're seeing others in it, you're thinking about it, and going crazy. But
So yeah, calculus.
calm down.
Inception, got it.
Calm down. Yeah, calculus. Yes, exactly. I've seen teachers teach this in a way that students kind of do it, which leads to horrible things. So here's what I'm trying to say. Don't do too much. Again, the whole idea is don't do too much. Isn't this function inside of that?
Yes.
Yes, okay. So when I start to do this, how do I open a Russian nesting doll? Don't I start with the outermost to get to the inner, right? Okay. How do I take the derivative of something squared?
Power down to 1, and then multiply.
Yeah, the 2 comes down, right? Look how much room I'm giving myself. The 2 comes down in front of stuff to the first power, right? So that's taking the derivative of the most outer function times the derivative of the inside. You do not have to know how many chains you'll need, how many links. You do not have to know that going in. You do them as you hit them. So the outside was done, times the now this is my problem, isn't it? This shit's just sitting here, right? That's the first power, not a prime. Let me not even put that. So this is just sitting here, waiting. What's going on with this guy? Isn't this sine of something? The outer one is sine. So what's the derivative of sine?
Cosine.
Cosine of stuff. That's how you take the derivative of sine, right? Cosine of stuff times, what's the inside function? So we did the derivative of the outside, and the inside is cosine 5x. So I got to do that guy's derivative. Do you guys understand that you do not have to know how many steps you're going to do? Why would you? You do them as you hit them. So 2 comes down, derivative inside. Now this is a problem. Forget about this shit, it's done. That's inside, that's outside. Outside function times derivative of the inside. Now I can look at him. I can focus as it comes up. Okay. So I got 2 sine cosine 5x times cosine 5x times, what's the derivative of cosine? Negative sine of thing times derivative of the inside.
Which is just 5.
Which is just 5. See, is there any more links to do after this? Of course not, because 5x is not a composition. It's frickin' 5x. There's no other thing inside. You guys understand? So I always get somebody who tries to write all the frickin' links at the start. And I'm like, how the shit would you know? They always go too far, and then things go crazy. There's no reason. I really want you guys to see this. When I did the first step, I sort of uncovered another problem I could focus on. When I did that step, I uncovered another problem I could focus on. When I do that step, oh, sweet. I'm done, right? This is just, for the sake of time, this is just 5, right? So let me bring that out. And what should I put out front?
10.
Almost.
Negative?
Yes, -10. I always get somebody who does this, and then that makes it look like it's this minus that, but it's times, yes? Okay, so -5 times 2 is -10. Sine, cosine, sine. Woo! All right, now, that's a lot. But you always, in every math class, it's all about being able to focus on what's important at the moment. This shit's unimportant. It just comes for the ride. This is what's important. I think students try to do the whole thing at once very often, and that is insane. Yes?
Couldn't you simplify that to negative 10 sine times cosine 5x, save space?
No. What? No.
If it's both multiplying by cosine 5x.
No. And this is not just you, by the way. I'm happy you're saying this. This happens a lot too. What is the difference between? Actually, first question, is this the square root times x? Is that the square root times x? Does that make sense? No. Okay, that's the square root of x. What's the difference between this and this? This is sine of cosine. This is sine x times cosine x. Do you guys see that? I mean, it seems small. And a lot of you guys are really, you write this. If you ever write this in the context of a problem, that makes no sense. That's like writing this. Right? You're like working a problem out, 7 plus, blah, 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 and you get here, 7 times the square root symbol. Yeah, that's the answer. So, what? But we just don't think about that. That's already 3 letters. Why does it need another letter? Because those 3 letters are just like this symbol. That is a symbol. This is a symbol. It needs something in it to make sense, right? So when you see this is not sine. Like this is sine x. This is its own thing. This is sine of that. That is inside of it. Okay. Maybe. So, how much time do I got? Okay. Real quick, if I ask you to do this derivative, what's the rule that I'm going to use? Product. All right, this would be derivative sine is cosine. Derivative cosine is negative sine. And then you get, that actually leads to an identity. I don't care at the moment. What about this? What's the rule here, of course? Chain rule. But I get way too many people that see this and they treat this as if it's its own sine x. It's not. It's sine of cosine x. That's chain rule. Do you guys see that? All right. So do this for me. Just a quick reminder. If my function is 5 to the x, what's the derivative? Does anyone remember? It's not e to the x, so it's not beautiful, but it's close.
It's 5x times ln 5x.
Yes, ln to the base. I love it. And which is why e is its own derivative, because ln e is 1. So try 1g and 1h. So just do those 2 right now. Make sure we can squeeze them in here. And again, if I were you, I would have a sheet of derivatives and rules that will sit next to me as I do homework, so I can reference it and get it in my head. Because I don't know if you guys remember derivative of cosecant, for example, but go for it. what's the derivative of 5 to something?
Until you
Yeah, 5 to the thing,
times.
and of course, what gets linked on there? What gets to have its own term? What hasn't gotten to do a derivative yet? The inside function, right? So it's real important, outside function versus inside function. And you actually don't care too much about the inside function until you're done with this dude, 5 to something. It really almost doesn't matter what the shit this is. This is 5 to some function of x. So how do I do that derivative? 5 to that thing times natural log of 5. Now this guy gets a term. I showed you a concrete example about why that kind of makes sense, and then of course we did a freaking proof together, or at least you watched me. Right. So I get 5 to the x squared minus 30x times natural log of 5 times 2x minus 3. And there's really no, you can bring this out here, it doesn't really, no, the one thing I definitely don't want to see. What's wrong if I write this? All right, this is wrong, this is wrong, this is wrong, this is wrong, this is wrong. What did somebody do?
You multiplied the 85 by the derivative.
Yeah. How many 5s are in this expression? How many 5s are here? How many 5s? Is there a 1? 5. No, there are this many 5s. So if you do this, you're pretending like there's just one 5. Doesn't make any sense. Also, you're going against order operations. Please excuse my dumbass son, right? Or to your own self. Right?
The first time I heard that
Yeah,
one.
all right. I like right? Because can you multiply before exponents? No, right? Sorry, I threw that at you. There's also one my algebra class made up. They made this up. W. Please excuse my deficient algebra skills. So they came up with that. Right? Okay. This is wrong. 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 So wrong. This is fine. All right. So what's going on here? What's the main outside function? Squared. So that's all you care about at first. It's something squared. That's easy. How do I take the derivative of something squared? Bring the 2 down. 2 times something to the first power, right? Then what gets a term? Now here's where you got to remember the derivative of cosecant.
It's negative cosecant,
Yeah, and be really specific. Negative cosecant of ax times cotangent of ax. All right, I don't know if you guys are cool. So the cosecant of x, the derivative, is negative cosecant. Why do I want to put an extra s? Cotangent. The same way that derivative secant was secant tangent. So the co shit is negative from the normal shit. Nothing against you co stuff. Who knows what normal is? Co shit is negative of what the other shit is. And then there's a beautiful, this was secant, so this is cosecant. This is tangent, so this is cotangent. All the co stuff. I like it. Which is a big reason why we call the co stuff co stuff. Okay. Now, coming back to this, am I done?
No.
What hasn't had a turn yet? Because this was the outside function. We just did the outside function. Ax prime, yeah. And of course, what's the derivative of ax? A. I like it. So I can just bring that out here. Oh, I can bring the negative 2 out also. Bam. The negative out, sorry. Now you could also make this squared, but I'm already writing this out. All right, cosecant times cosecant. I really want you to understand, the rule doesn't give a shit what the functions are. The rule is always the same. If you're to the outside, then the inside gets a turn. If the inside function itself has an inside function, it's another chain rule problem that you can then focus on. Okay, so right now, I'm hoping most of you are like, I don't quite get this fully yet, but I can see myself getting this. Yes? Right? This isn't brand new for most of us. It definitely takes some time to get used to. What do you guys think? We have, let's do 1I and number 2, we'll do that Monday. And don't forget, quiz. I'm not going to do chain rule on the quiz. Again, I'm kind of trying this be a nice thing out this semester. So far it feels icky, but I'll see. So I didn't put chain rule on this. It's just, X to the N rule, the product rule, and the quotient rule. That's all it is. Just those big things. All right, so let me know if you have any questions. Otherwise, you are free. You are free.
Alright, so I know I asked this question like last time, but